Hello everyone. I want you to discuss equilibrium with this simulation here. Remember in the video, he said scientists spend most of their time and energy to find a way to increase the product concentration. So I'm gonna give you an example here. We will start our reactants. We have A and B, C, and the double arrow, it means it is a reversible reaction. So A, B, C, these two will make AB molecule and C element, but it can also go backward and it can make A element and BC compound. Now, we are going to start with, you can also change the colors here. We are going to start with equal number of A. Let's start with 10A, 10B, and the temperature will be at like normal level. And I want you to show you the concentration. So remember, at the A, you can also make it larger or smaller. At the beginning, we will have 10. And as the collision happens, remember, in order to have a reaction, remember collision theory, I show you a pull tricks. We need two things in order to have a reaction. We need enough energy, enough kinetic energy, correct orientation. Okay? Enough kinetic energy, correct orientation. Now, we are going to put this A and BC, my reactants here, A and BC, in this closed container, and we will start the experiment, and we will monitor their amount as the reaction happens. We are going to see AB compound formation. The product will form. Also C element will form. And we will also, it's gonna start from the 0 because at the beginning we don't have any, right? We don't have any. And we are gonna change the concentration change, number of molecules change as the reaction happens. So let's begin the experiment. Okay, now we have A and BC here. These are the current amounts. We don't have any product right now. Now, my product is very low. What should I do? As you see, they do not have enough energy. Let's increase the temperature, okay? Because average kinetic energy is temperature. Let's increase the temperature a little bit. And let's see the concentration. Still, we do not have like 10, 10. We do not have any change in the product. Let's increase a little bit. Look, we start having products, you see? Now we start having products. Maybe we can, no, we cannot. Can we change the initial? Or if you change the initial condition, it's gonna restart it. Okay, let's restart it. Let's put it at the average. Begin experiment, play. Let me start over. Reset everything. Okay, I'm gonna start with 10 here. Let me type 10 here. Beginning is this amount of energy. Begin experiment and let's see the concentrations. Remember, they will start at 10. I have some product here. Look, they have enough energy now. Now let's observe what's gonna happen when we change the parameters. Now I want them to have more energy. Let's see what's gonna happen to the products. Look at the products here. And again, it reaches the equilibrium, you see? And it comes back and forth, back and forth. Now, at one point you have more, at one point you have less, but there's always an equilibrium. Makes sense? Equilibrium. The reason we have equilibrium is they are in a closed container. Closed container. They constantly hit each other. Sometimes they break bonds, sometimes they form bonds. That is the reason we see an equilibrium here. What else I can do? So the purpose of this, I want more product, right? That is the purpose of my experiment. Now I increase the temperature, I increase the product. Let's see. What if I have more A samples here. I am going to add more A, okay? Look at the A value here. A is my yellow one. Look, I have A value. Look at the product. Do I have more product now? Or does it affect it inversely? I think I have more product now. Look at my product line. Right? I think I have more product now. What if I have more BC? Okay, let's see. What if I have increased the concentration? Look at the product number now. These dashed lines are product number, remember? I have more product now. So these are called Le Chatelier principle. It's a French scientist who helped Haber, German scientist, to increase the reaction rate to have more ammonia. It's a very critical reaction for the environment, for the food production. I'm going to add a link there. So you understand how the concentration of the initial reactants or the temperature affect the product formation. You can play with these numbers, you can play with the temperature, and you can have more product or less product. And these techniques, all these modifications are called Le Chatelier principles. Okay, Le Chatelier principles. Bye everyone. I hope that simulation was helpful to understand the concentration effect and temperature effect on reaction equilibrium.